All right, our next topic to cover in this unit is scatterplots. So the title for today, scatterplots, write that in your table of contents. Then on the next clean sheet of notebook paper in your spiral notebook, write the title, scatterplots, and the essential question for today is, how can I determine a line of best fit from a scatterplot? So kind of switching gears today to scatterplots, which are like a type of graph. Okay, when you're ready to move on, hit play. If you need another minute to set up your notes, hit pause. All right, first, a few vocabulary terms, and we will have a vocabulary quiz for this unit, so you need to make sure you have these. First, what is a scatterplot? A scatterplot is a graph that shows relationships between two sets of data. What is a correlation? It's the relationship between the two variables. Okay. Correlation is the relationship between two variables. And then what is a line of best fit? We also sometimes call this a trend line. So you might hear trend line or a line of best fit. It is a line that best represents the data on a scatter plot. So make sure you have those three terms in your notes. All right, three more terms. Told you there's a lot of vocabulary in this unit. There's three different types of correlation. So we define correlation back here. Remember, that means the relationship between two variables. So three different types of correlations. First, what is a positive correlation? The data displayed on the graph resembles a line rising from left to right. So imagine like you're reading a page of a book. We always read the words from left to right. We're looking at the graph here from left to right. If, when we're looking at the graph, the dots are kind of going up, they're rising from left to right, we would say that's a positive correlation. If we have a negative correlation, the graph will look like data points on the graph resemble a line falling from left to right, so they're going down from left to right. And then no correlation, the data displayed on the graph neither resembles a line rising nor falling from left to right, so you're not going to see kind of a trend of going up or a trend of going down with the data points. They're just going to kind of be all over the place, and we'll look at what that looks like with some examples in just a second. So finish copying these definitions. Hit pause if you need another minute. When you're ready to move on, hit play. Okay, what is a scatter plot and how can it be used? Scatter plots are similar to line graphs in that each graph uses the horizontal x-axis and vertical y-axis to plot data points. Scatter plots are most often used to show correlations or relationships among data. So here is a scatter plot, and you notice on this graph that instead of seeing a line, we just see a bunch of points. Okay, here's another scatter plot, and again we see just a bunch of points. And then here we see a bunch of points as well. So scatter plot kind of sounds like what it is. It's a bunch of points that have been plotted that are scattered all over the graph. Now, what kind of correlation could we say that this has? What do we notice about the points as we look at the graph from left to right? We notice that they are going down from left to right. So this is a graph that would show a negative correlation. This is a graph that it looks like it's slightly rising from left to right. So I would say it has a positive correlation. These, it's just a bunch of points. There's no way I could say it's either rising or falling. So I'd say no correlation. And a correlation can be predicted without having to observe the data in a table or graph. Given the examples, what is the correlation, positive, negative, or no? So you're going to think about the two variables in each of these examples we're about to look at and think about as one variable increases, what happens with the other? Is the other variable also going to increase? That would be positive. Is the other variable going to decrease? That would be negative. Or do they have nothing to do with each other? That would be no correlation. So call this example 1 in your notes. Your grade point average and the number of A's that you receive. As your grade point average goes up, what happens with the number of A's that you receive? Does it go up or down? It would also go up because your GPA, your grade point average, is higher depending on the number of A's you get. So that would be a positive correlation since it's up and up, positive and positive. All right, what about the time you spend studying on your test and the grade on your test? We would say, and I know some of you are going to be like, I never study for anything and I always make make A's? Well, just in general, if something is really hard and you need to spend some time studying to be successful on the test, as the amount of time that we spend studying increases, what's going to happen with the grade on your test? It will also increase. The higher your grade, probably the more time you spent on your test. Or spent studying for your test. Another example, the size of a person and the number of fingers he has. Okay, so my 2-year-old nephew is little. My dad is big. Okay? As the size of the person increases, what happens with the number of fingers they have? There is no relationship. My 2-year-old nephew has 10 fingers. My 60-whatever-year-old father has 10 fingers. There's no relationship between the size of a person and the number of fingers. It's not like as you grow bigger, you grow extra fingers. That would be weird. Okay? So that would be no correlation. What about the weight and height of each member of a soccer team? As the weight of the person increases, what happens with their height? I think there could be an argument for either positive or no correlation, but I think what they were going for is positive because the taller the person is, the more he's going to weigh. Okay? Theoretically. I mean, I know that there are really skinny, tall people and heavier, short people. I don't know. So we could probably say positive or none. I don't know. Okay, what about the size of a car or truck and the number of miles per gallon it can travel? As the car or truck gets bigger, so think about a smart car is really small, okay, or like one of those little hybrid things, really small. What happens as the size of the car or truck gets bigger, so as we go up from a tiny car to like an SUV or a big truck, do they get more miles per gallon or less miles per gallon? They get less miles per gallon. So as the size of the car or truck gets bigger, the miles per gallon they can go gets smaller. That would be a negative correlation. We haven't had one of those yet. So when you have one increasing and one decreasing, that would be a negative correlation. All right, I think we get the point of this. Okay. Correlation can also be shown in a scatter plot using graphs for visual reference. We talked about that a second ago. And here, a trend line can be shown, which is the line of best fit through the data points. We wrote down the definition, but we haven't looked at what a trend line looks like yet. So here we have different scatter plots, and we have, what kind of correlation would these be? These would be positive correlation because they're going up from left to right. And since we see those points kind of are all moving up in the same direction, what you want to do is try and draw what we call a trend line or a line of best fit that represents the direction that the points are going. The closer the points are together, like in this graph right here, the easier it is to draw that trend line. Here, they are going up from left to right, but they're not as close together, so we just kind of have to do our best to draw a trend line in that direction. This middle graph, what kind of a correlation would it have? We would say this is no correlation. It's just a bunch of dots. It's not going up or down from left to right. And then the last two would have a negative correlation. And notice they've drawn a trend line going from left to right, going down, okay? I think it's on the next slide. We're going to talk about the difference between a strong correlation and a weak correlation. Yeah, here we go. When the dots are really close together and it's pretty easy to draw a trend line, we call that a strong correlation. Whereas when the dots are going up from left to right or going down from left to right, but they're not as close together, we would call that a weak correlation. And we talked about the positive and the negative already. So weak is when the points are further apart, but still moving in a direction. Strong is when the points are really close together, but moving in the same direction. All right. Last thing we need to cover is how to actually create a scatter plot. What you would do is take your data set. We have the height and we have the weight, and I see that they've labeled my axes for me, X and Y. And we just plot our ordered pairs. So we'd go over to 63, up to 125, and plot a point. We'd go over to 67 and up to 156. Let's see, I don't know. 130, 156, I guess it's about there. 169, 175. That's this. I guess about there. 68, 135 would be like right here. And then 62, 120 would be right here. So we made our scatter plot like that. And usually you'll have more points than just 5. Okay, the more points, the easier it is to see the trend of the data. Okay, at this point you should be ready to complete the digits 14.1 assignment. That's on 8th grade. There are also some IXL skills that go with this. And then you have your spiral review. If you need help, let me know.